Okay, kita sambung lagi ya. Dipole moment. Again, this is repeating facts. Ya. To absorb IR radiation, molecule must undergoes net change in dipole moment when it vibrates or rotates. Almost all molecule contains covalent bond will show some degree of IR absorption. Ya. Except diatomic molecule, atom yang symmetry. Ya. A molecule yang symmetry, for example, hydrogen gas, nitrogen, and oxygen gas, yeah, in which there is no net change in dipole moment when the bond vibrates. The dipole moment is determined by the magnitude of charge difference, yeah, depends on electronegativity of the atom juga, yeah, and also the distance between the two center of charge. Yeah. This is a bit technical. Yeah. You boleh Google nak tahu how to determine the dipole moment. Okay. So, what happens when molecule absorb infrared radiation? So, absorption of IR radiation correspond to energy change on the order of 8 to 40 kilojoules per mole. Yeah? Radiation in this energy range correspond to stretching and bending vibration frequency of the bond in most covalent molecule. In the absorption process, those frequency of IR radiation which match the natural vibrational frequency of the molecule will be absorbed. Okay, kalau dia match vibrational or rotational frequencies, the molecule will absorb that radiation. The energy absorbed will increase the amplitude of the vibrational motion of the bond in the molecule. Okay. So this is very okay. This one, this is quite important. Yeah, a bond is symmetrical. Yeah, the bond which is symmetry has zero dipole moment. Yeah, for example, triple bond of acetylene has zero dipole moment, and the dipole moment remains zero if the bond is stretched or compressed. Okay, so it will not absorb IR radiation. Yeah, this bond only, but this bond still can absorb. But the CC bond, because it is symmetry, so it will not absorb IR radiation. Yeah? So this is another atom, another molecule that cannot absorb IR radiation, because it does not have net change in dipole moment when it vibrate or rotate. Yeah? So this is some question regarding IR theory. You boleh tengok. You boleh baca lah. Okay. Okay, this one. Okay. The IR spectra. The spectra of the IR spectra for polyatomic covalent compound normally quite complex. Even though we learn the theory macam ni, but in reality it might not follow the theory 100%. Yeah? Dia macam-macam lah factor that affect absorption. Yeah? The relative position of atom in molecule are not exactly fixed. Sometimes dia boleh shift ke bawah sikit, sometimes boleh shift ke kiri sikit, ke kanan sikit. Yeah? Depends on the neighboring neighboring group juga. Yeah? The position fluctuate continuously. Okay, position of the band also fluctuate. Depends juga, banyak faktor yang affect them. And the bond in molecule acts like tiny spring, and like a spring, vibrate with a characteristic frequency. This frequency fall in the IR region of the electromagnetic radiation. By passing IR radiation through sample and observe what frequency the compound absorb, it is possible to deduce the types of chemical bond present in the molecule. By looking at the peak, we can determine, we can deduce, not 100% determine, not 100% accurate determination too. So we call it deduce. What types of chemical bond are present in the molecule? Okay, so for example, this is IR spectrum for this compound. This is 2-methyl butane. Okay, so this is stretching vibration This is bending vibration. This is peak for bending. This is peak for stretching of CH bond. Sama CH bond. Most have CH bond and CC bond. Tapi yang lebih ni, yang lebih obvious is the CH lah. So dia percent transmittant versus wavelength. Normally ataupun wave number dia punya spectra plot dia. Okay. And this diagram show absorption in different region of the IR spectrum according to bond and molecule. Atom. Okay. Ni terlalu kecil. Tak apalah, nanti kita akan tengok lagi lain. And this is the region of IR spectrum. We have two region. First, we have we call it diagnostic region. This region is above 1,500. Okay, above 1,500 is the diagnostic region or important region. Because peak around this region is quite informative compared to fingerprint region. Okay. Fingerprint region yang bawah-bawah ni kat sini, belah-belah kanan ni, ini dibesarkan ya. This is fingerprint region. Region below 1,500, it is harder to interpret, much more complicated, but unique to molecule. Sometimes ada molecule yang kita perlu gunakan fingerprint region untuk deduce dia punya structure. Can be matched to molecule. Okay. So for example, kita ada isomer ke apa ke, so fingerprint region ni quite important. Okay. Tapi diagnostic region ni is important to determine or to deduce the functional group. Tapi fingerprint region ni untuk special case. Okay. Okay. So this is operation of IR instrument. First, we need to purge with dry nitrogen because IR is often purged with dry nitrogen to remove atmospheric CO2 and water, which may cause significant absorption peak in the IR spectrum. So kita nak remove all the gases yang boleh absorb IR in the instrument, we purge with the dry nitrogen. Kita purgekan. Purge ni means macam kita sembuhlah dengan dry nitrogen. And then the second things that we must do before run the instrument ataupun run the analysis, we must do background scanning. Okay, before run the sample, we need to perform background scanning ataupun running background spectrum. The reason is to substrate absorption band due to water, moisture and carbon dioxide and anything else that is not in the sample to produce the actual spectrum. Okay? Even though we are already purged with the dry nitrogen, but there is still some moisture and carbon dioxide left in the instrument yang kita tak boleh nak use. So, kita buat background scanning, nanti dia akan detect, dia akan compensate the background absorption. Okay? Sources of trace also dia buat juga background scanning. For example, solvent in the sample have traces of dissolved gas and solvent molecule. Okay, so that's why dia perlu buat background scanning. Kalau kita gunakan solvent, kita kena scan solvent tu dulu. Okay, this is example of background spectrum. Kalau kita buat background scanning tadi, kalau kita dapat spektrum macam ni, mesti sebiji sama macam ni, means that the instrument is okay. Kalau tak dapat macam ni, maksudnya there is something wrong with the instrument. Okay, instrument kena calibrate ataupun kena repair ataupun kena undergo some maintenance. Ambient water, two irregular groups of line at about 3,600 and about 1,600. So this is for water. Peak dekat sini dengan peak yang ini is for water. While these two peaks is due to carbon dioxide. Satu stretching, satu bending. Okay. Selalunya yang tinggi, yang belah kiri ni is a stretching, yang belah kanan is the bending vibration. Okay. Okay. So we go to the sample handling techniques. Yeah. So we have 3 types of sample that can be analyzed using FTIR. First, gas sample. Yeah. Gases of low boiling point liquid. Okay. Permit the sample to expand into evacuated cylinder cell equipped with suitable window. Yeah. And the pass length of the cylinder normally can go up to 10 meter, yeah, from cm to 2 meter size. Yeah. So this is a diagram showing a cylinder for gas sample. So normally kita injectkan gas sample tu, masukkan dalam ni. This is a vacuum cylinder that has a window, that has a optical window. Kalau tak, macam mana radiation tu nak lalu kan kat dalam ni? Okay. So ni pun sama juga. Dia ada window kat sini dengan kat sini ada window. And the second one is the liquid sample. Okay. So we have for liquid sample, the method is just by dropping a pure or neat liquid between 2 salts plate. Okay. To give a layer that has a thickness between 0.01 millimeter or less. Okay. And then the 2 plates held together by capillary mounted in the beam path. Kita letakkan dekat instrumen tu. Dia adalah tempat untuk letakkan instrumen tu, untuk letakkan sandwich salt plate tadi ni. Okay. Normally the plate used is potassium bromide ataupun potassium chloride ataupun silver bromide plates. So what is neat liquid? Neat liquid is a pure liquid that does not contain any solvent or water. Okay. So for example, neat liquid ni macam contoh kalau kamu cairkan garam, garam yang kamu tak letak dalam air, bukan dalam air. Kalau dalam air tu we call it solution. Tapi garam tu yang dia dah cair ataupun gula yang dicair, tak dia campur apa-apa air, that is called neat liquid. Okay. So this method is applied when amount of liquid is small or when suitable solvent is not available. So in these 2 conditions, we can use a salt plate. Okay. So this is preparation of liquid sample. Clean the plates with a small amount of acetone, then use a pressure pipette untuk dropkan sampel kamu kat tengah ni betul-betul, ya. Kemudian tutupkan with another plate, kemudian mountedkan dekat ni tempat dia. Kita sandarkan dia. Kat sini radiation lalu. This is from the source, and kat sebelah sini ada will goes to the detector. Okay. Okay, this is liquid cell, gambar untuk macam-macam jenis lah liquid cell dia, macam-macam bentuk sebenarnya, depends pada instrumen lah. Okay. And okay, this is boleh tengok lah, yang mana yang okay, yang dah scratch tu tak boleh, dia tak boleh ada fingerprint, dia tak boleh ada ni, so we need to hold the salt plate macam ni kat tepi je, tak boleh pegang tengah-tengah dia. Okay. And for solid, we have 3, okay, tak apa, kita stop dulu, nanti kita sambung untuk solid sample. Okay, sempat lagi ke?